We are moving on to chapter 9, everybody. In chapter 9, we're going to study substitution and elimination reactions for Rx. X is a leaving group. What does that even mean? Well, it means it's going to leave. This is an introductory part, so I'm just going to describe things we're going to look for. The X here is the bromine. It leaves as Br minus. I don't know why that's doing it. Leaving group. It's not worth any points unless you're asked for it. Leaving groups must be stable when they leave. And what is the definition of a leaving group for us now? Leaving group. Definition. Well, before I do the definition, I got a question. Why is HBr a strong acid? Okay. Are you going to say because it has a negative pKa? You stated the question the second way. Now my new question is, why does it have a negative pKa? And you're going to say because it's a strong acid, and we're going to go all week. All right. Now what I want to hear is Br minus, because Br minus is a good leaving group. It's stable by itself. That's why it leaves H plus. Now we're learning it's more general than that. It doesn't have to be HBr, it can be CBr, and the Br doesn't mind leaving the C either. Okay, so I'm just going to say the conjugate base of what kind of acid, because Br minus is the conjugate base of HBr, which is what broad category of acid. There's only two broad categories, and you said it. Strong. So conjugate base of a strong acid. There you go. You can't be in chapter 9 unless you have a molecule that has a leaving group on it. Got it? So we've already got that molecule. That's Rx to the left. And you always have to analyze Rx first. Give me a category for the carbon attached to the bromine. Can I summarize all the categories we know so far? Give me a second. Methyl, primary, secondary, tertiary, primary allylic, secondary allylic, tertiary allylic, vinyl, benzyl, phenyl, primary benzyl, secondary benzyl, tertiary benzyl, alkynyl, C-triple-C with a halogen or something attached. Of all the things I just said, it was the second one, which was what? Primary. When you think of a primary carbon, do you think of carbocations? Please don't. I don't like primary carbocations. I love tertiary. I'm kind of on the fence about secondary because they're okay. They're neither really good nor really bad. It's kind of like you walk up to a secondary carbocation and you ask the guy, "Are you a good carbocation?" He says, "Mobotov." Yeah, I don't know. So when I see primary, I'm thinking no go on carbocation. And what you don't know yet is there's a reaction in this chapter called SN1, which goes by way of a carbocation, and you shouldn't be thinking about that for that very reason, because that thing is primary. It only has the other option, which is SN2. So your conclusion based on this one fact predicts SN2. You don't even know what that means yet. We're way ahead of the game on it. I'm just giving you something to think about before you read the chapter. In step 2, you always analyze the nu. What's nu stand for? Nucleophile. That's this guy right here. Nu. Now, in general, well, I'll tell you, there's only 3 categories for nucleophile. strong, medium, and weak or poor, whichever one you want to use. Instead of medium, you could use moderate, something that says you're in the middle. You could use Mobata. All right. So I'm just going to say that almost all the anions that are nucleophiles, I mean, that makes them more reactive, right? They really love a nucleus if they have a minus. So if you see an anion, you should be thinking at first strong. And in this case, you would be right. Strong. And I'm going to tell you that also predicts SN2. We'll talk about why on Monday. So you'll talk about why when you read the chapter. Read the chapter. This is a very systematic chapter with a lot of little facts that you use repeatedly over and over. It's nothing severe. And following the order here, make sure you do things in the right order. And you always look at the solvent as well. We do reactions with solvents in chemistry, your level of chemistry in particular. I don't think you've done any reactions where there was no solvent. Have you? No. In 141, it was always the same solvent. Kind of boring, right? Water. In our lab, we use water very rarely. In this one, the solvent is methanol. And you're going to learn about 3 categories of solvent. You want to hear the names? If you have a hydrogen attached to oxygen or nitrogen in your solvent, that's this one. It's called polar protic. And that actually predicts SN1. And it does not mean you're changing your mind. No, the order 1, 2, 3 means you looked at the most important thing first. You looked at the second most important thing second. The least important thing says SN1. All that you've done with that one is slowed down your SN2. Your prediction based on fact number 1 and fact number 2 is SN2. You like how I did my answer? Like that. I based that answer on the red and the blue. Okay. In an SN2 reaction, you remember what backside attack is? That is a backside attack reaction between 2 different molecules. Here's the sulfur coming in from the backside of the leaving group. And the leaving group is doing what leaving groups do. It's leaving. And you get this result. And the green was the carbons, and the nucleophile was in blue. Should have done the carbons in red. RX was red. New bond to sulfur in blue. Sulfur has an ethyl in it. There you go. And that's it. What functional group does that look like? Like on the periodic table, if that was a O instead of an S, what would you say I have here? An ether. So this is called a thio ether. Thio. If you see thio as a prefix anytime in chemistry, it just means sulfur took the place of oxygen. Its buddy on the periodic table right above. And end of that story. Good introduction. We'll be doing nothing but these for the first hour on Monday, maybe a little longer. And we're done.